thanks for the invitation to talk. Sorry I can't be there face to face, but appreciate Dean making the sorting out the links so that we can do it remotely, because that's terrific. We do a fair few of these in AgVic, and some of them will know the team I work in with. I lead our seasonal risk team, so Dale Gray there from Bendigo in the break, which is really commentary around seasonal forecast and making sense of weather 101, and we've got soil moisture probes up that's in with Dale Boyd, and that's sort of measuring how much moisture is in the top 1 metre of the profile, and a lot of good stuff that's happening with CMAs and others there. And climate webinar series, and where we have a regular bunch of things around these sort of topics and sharing what's going on. Well, I guess our background is we've spent a lot of time in the last 15 years with different climate scientists from the Bureau and CSIRO, and reading the peer review papers and helping tease out what's long-term variability and what's the recent trends, and also make sense of climate change projections. So that's what I'm going to give you a bit of a run through, and it's a big topic and it affects agriculture a lot, and there's certainly, it's great you've got the chance here to update on just general climate literacy about what's going on. So I'm going to start with that little tool that I really like. It's Climate. Has anyone there used the Climate tool? Seen it before?
No.
It's an app for your phone. Or you can use it on your desktop. So you can see that address there, climateapp.net.au. But you see all of these dots here. These are long-term rainfall records, and basically you can go to them, download it. And I just did this this morning in Castlemaine Prison, and you can get a pretty long rainfall record and do all sorts of things like how's the season progressing, and just plugged in, starting from January this year, you get this sort of an image, and it just shows from January through to where we are now. All of these other lines are previous years, and when you hover on them on the app, it tells you what year's what. But you can see the average is the blue line, and then the red is how I've been tracking this year. So it's a good little tool because helps keep track of where things are sitting, and you can see it was a bit of a dry start to the year, but once things did kick off in May, it was it was a wetter than average sort of winter, and then this sort of spring's tailed off. It's sort of flatlined there at the end. So that's a good little tool. Then there's other little queries you can do with it, like especially when everyone's anticipating the autumn break, you can do something. You can ask questions like how often. So for your local record of the Castlemaine Prison, you could ask, how often do we get more than, say, 50 millimetres of rainfall over a 2-week period, say between April and 30th of May? And it'll tell you how often that particular scenario has happened in the past. So it's a really good little tool, because one of the things is starting with what's happened in your location history. It's a good place to start. And you can notice there that some of the autumn breaks perhaps not quite as reliable as they might have been. So that's a good tool. There's some new guides too I'll just promote too, that the Bureau has done these for all of the CMA regions across Australia, regional climate guides, and so there's one here for looking at the climate for the North Central region. So they're really good guides. There's the website there. Just little 4-page fact sheets, but they're really good to get a hold of. They've only just been live the last few weeks, but sort of talks about recent trends and what's going on in each part of the country. So that's a good little tip. And rainfall's sort of variable, decreased slightly in your part of the world, mainly around autumn and spring. Spring frosts have been a bit more common and occurring a bit later, but temperatures have been on the rise. So there's all of that sort of stuff is in those fact sheets. So it's a good place to look. And yeah, it gives just examples of, it teases out some of the examples of, temperature trends and that locally. So this is all stuff that agriculture and farmers have noticed, but it's interesting. We've all got good long-term rainfall records, but temperature's one which we don't really have a good long-term record of usually on our farms. We remember hot days, but the sequence of them and how often they happened is all back to the Met stations. So here's a long-term rainfall record that we've got from the Castlemaine. Goes back to 1873, so you can sort of see here 1873, this is years along the bottom, so 1873 there was a bit over 600 mil of rain. This is millimetres up the sides, and this is the long-term average through here, 583 millimetres, but you can see just incredible variation right throughout that record. And some years, you know, over 900 mil, and then some years, you know, probably barely cracks 300. So a huge amount of variation there in that long-term record. So I'll just leave that up for a quick tick, Dean. Just wondering if there's any observations or comments people would like to make.
Graeme, I've got a question. Can you hear me?
Yep.
Yeah. So, given this, not many of us in the room necessarily have a farm in Castlemaine itself, so we're sort of around the fringes in the region. How much sort of variability would you expect as you extend out 10, 20 kilometres?
Yeah, well, it's a good question because it does vary quite a bit around the state. Like, and even if you go over the hill, you can get a slightly different record. What's sort of similar for most places across Victoria is you can see there was certainly drier period around a run of dry years with the Federation drought and World War I and World War II, and up until the 50s it was certainly a dry decade, and then there was a wetter period in the sort of 50s and through to the 70s. And what's interesting with this record for Castlemaine, this is probably that's probably as well as anyone's fared in the last 20 years in terms of that last 25 years. I can go to some places and out of the last 20 years there's only been 3 above long-term average and 17 below average. So it does vary around the state, and you've probably been faring a bit better than some. So, and also with this stuff, you know, it can take just a summer thunderstorm of, you know, 80 mil out of nowhere to suddenly take you from below the line to above it. So, but that's that broader pattern there. Now, when we look at the seasons, so for that record, here's summer, autumn, winter and spring. So you can sort of see, while summer's the sort of dry year, there's great variability in there, and you can also see the record wet summer of 2010-11 in there. We'll talk a bit about where that tropics came to visit that year. Autumn sort of probably the one season where typically across most of southeastern Australia we find in the last 30 years there's certainly certainly been something a bit different going on with the autumn breaks and the amount of autumn rainfall. So that shows up, and spring's probably another one where certainly look the last 10 years there haven't been too many above the line. So we'll talk a bit about that. So plenty of variability in the mix, and I guess what drives this variability, this is one of my favourite pictures. You can see Antarctica here, so it's a view from 3 different satellites stitched together of the southern hemisphere. And so you can see we live here, and what's behind our wetter and dry years is all to do with some big ocean and climate drivers that are around us. So you can see all of the cold fronts queued up in the Southern Ocean, and what drives all of them is these really strong winds. You might have heard of the Roaring Forties, and that's pretty much, they're called the Southern Annual Mode, and it's a really driver for these cold fronts to flick their tails across South Australia. But the driest air on the planet is actually down in Antarctica. It's too cold for any moisture to be in the air. So to make rain, we need 2 things. We've got to have a good source of moisture in the atmosphere, and then something's got to make that moisture fall out, otherwise it's just going to be humid. So you can see up here along the tropics is the warmest oceans and the most cloud, and that's really the generator of most of the world's moisture, and we rely on moisture feeds coming in, and the trade winds blow from the Pacific towards Australia. They feed moisture in, and as that moisture bumps into these cold fronts down south, that's part of our fairly reliable rainfall patterns. So we've got the El Nino Southern Oscillation. Some years it's sending a lot more moisture than others, and other years it's sending all the moisture somewhere else. And then the Indian Ocean Dipole, which has been in the news a bit recently, and is quite a strong driver. When it's in its wet phase, like it was in 2016, there's lots of extra cloud and moisture up here, and that feeds in beautifully and connects with, sort of almost crashes into the cold air right above Victoria. So it's quite a strong driver for our part of the world. And can I ask, Dean, too, that one of the things about the Southern Annual Mode, all of these are really important drivers of variability, and they've really, influenced all of our seasons in the past, but also part of the challenge of climate change is some of these starting to behave a bit differently. So Can I ask if farmers, if people there were farming in the 80s and they saw a cold front off the coast of Perth, what would they be thinking?
You'd expect it to come through to Victoria?
Yeah.
Yeah, well, that's right. Well, I mean, I grew up on a farm near Clunes, and we certainly at home. It was you had 3 days' notice basically to get everything ready to go. 3 days from rain in Perth to here. But if you see a cold front off the coast of Perth tonight, most of us sort of since the mid-90s have watched quite often those cold fronts sort of slip a bit further south.
Don't we sometimes now look further north-west in Australia if there's a front up there that might be coming down to us?
Yeah, well, that's right. These northwest cloud bands are really important for that moisture source, and they can certainly bring in some good trough systems and things. But that reliability for a lot of Vic is about these triggers come through with these cold fronts, and then we're just hoping there's a good source of moisture that connects to it. And it's a bit like sometimes when we have weather events. If you've got a mobile phone, sometimes you've got a 5-bar connection and it's all loud and clear. But sometimes the mobile phone connection's really scratchy. You might only have 1 bar or not. So in the wetter years is when we've got really good sources of moisture right around this area to our north, and so any weather event that comes across has a 5-bar connection to moisture. And if you look at the current spring we've got, the Indian Ocean dipole's in its dry phase, so there's just there's no cloud up there at the minute, and so we might have some good frontal activity, but there's just no moisture there to feed into it, so we've got a 1 bar or a scratchy reception there. So that's sort of part of that variability story. I'll just sort of show an example of it. This is sea surface temperature maps, and along the equator the ocean's a lot warmer than it is down south, but this is just showing sea surface temperature anomalies. So these sort of orangey colours are where the ocean might be 2 degrees warmer than it is normally, and the blue colours is where a bit of ocean might be cooler than it is normally. So we're going back to show what a dry pattern looks like in September 2006. You can sort of see all the warmer waters over here, and this is a classic El Nino pattern. And along the equator, all of the seasonal forecasters watch this stuff like a hawk, because basically where the warmest water pops up, warmer than average, that's where all of the cloud then gets generated, and it starts to actually build up a head of steam where, in this situation, all the cloud would be over here, there'd be floods off Peru, the trade winds would actually be starting to get sucked backwards, and it means that there's no moisture or a lot less moisture to feed into our weather patterns. And you'll notice this bit to northern Australia where the ocean's a bit cooler than average. That means that actually there's less cloud there. So New Guinea would have, they had droughts in those sort of situations, and it's hot. And there's just a lack of humidity, which feeds into our weather patterns down south. So that's a dry pattern. Now have a look at this next image just to see if you notice the difference when we go to, say, a wetter spring or wet pattern like 2010.
That's what we want.
Yeah. So you can see just that difference. So this is a big La Nina. We've got the Indian Ocean dipole, all of the warm waters up here, and that was actually record sea surface temperatures that year. So that meant that there was tropical air and cloud. We had a 5.5 bar reception that year, and for that spring and summer, and it was just a matter of then individual weather events about which farm got it. And I know there was no shortage of water running on farms up there over the summer of 10, 11. So that just shows that's natural variability, and these systems that drive that from one year to the next, and they're going to keep driving our weather. There's just also looking at, well, how does climate change affect some of those drivers? This is just from Bendigo, a long-term rainfall record. But this is a website we've just created in the last few months called Forecast for Profit. And it's got it, you can look at a few sites across Victoria, and we've coloured the years that were either an El Nino or a La Nina in the Pacific. So La Nina's when it's in the wetter phase in the Pacific, El Nino's when it's in its drier, neutral's just when it's in between, and the Indian Ocean dipole when it's in its negative wetter phase or drier positive phase. And sometimes they combine. So you'll notice here that for Bendigo, and these ocean drivers are a long way from Bendigo, so it's a pretty similar story for Castlemaine, your district, that you'll notice these bigger droughts of 82, 2006 and 2015, they're all actually where an El Nino combined with the dry phase of the IOD. So when both of those oceans are out of action for not sending some moisture, it really increases the chance of those dry years. And you can see that wetter year, 10, 11, we had a La Nina and an IOD, and both combined in their wet phase. And that 2016 sort of wetter year was when the IOD was in its wet phase. So this is a lot about the variability, and what forecasters do is then look at, well, how's that shaping up this year? And when we tease out the last, that long-term rainfall record of Castlemaine, and we look at, say, spring or July to October rainfall during El Nino events. So normally a third of years are dry, a third are average, and a third are wet, which is the blue. But when we just look at the El Nino years in that Castlemaine record that I put up earlier, you can see that 7 out of 10 of them were dry. So it's quite a strong driver, but it doesn't guarantee that it's dry. La Nina's a wetter, and the Indian Ocean Dipole, it's in its dry phase this year, and that's been the past effect of it at Castlemaine. It's interesting that in 2016, when the Indian Ocean Dipole's in its wetter phase, you can see at Castlemaine, whenever it's been in its wetter phase, it's only ever been wet or average. There hasn't been a dry year there. So it's quite a strong driver for your part of the world.
So
A lot of that.
Greame, just a question for you.
Yep.
Because at the beginning you probably heard a number of comments and questions that people had, which we put on the board here. We really just summary of people's curiosity, things that they wanted to find out about that affects them from your talk. Will through your talk, will you give us some ability or skill us up a little bit in terms of being able to read the forecasts better so that we can apply that at our own sort of on-farm level? I don't mean locally on our own specific farm, but for our district, so we can look ahead and go, okay, 3 months out, the summer's going to be really dry, or the predictions are from the expert forecasters that we will actually be getting some rain coming through sometime and whatever. And that allows us to plan, put summer crops in and those sorts of things.
Yeah, that's right. I will get into that because there's a bit to do with like weather forecasts, what they can and can't do. Then there's the seasonal forecast, which is sort of getting into the next 3 months, and then there's the climate change projection. So probably one of the best bits for seasonal forecast, which is sort of trying to get a vibe of the next 3 months. Dale Gray puts this together with Agriculture Victoria called the Break newsletter, and you can subscribe. It turns up monthly. But basically, he looks at the Bureau's forecast model for the next 3 months, but he also looks at 11 others, so the UK model and the European model and the US model and NASA and the Japanese and the Chinese. They've all got models for where they think it'll rain across the planet in the next few months and where it won't. So he does that, it's like a footy tipping sheet, and this is his current one at the minute, just the Fast Break just put out a week or so ago. And so of that scan, he's looked at Victoria on all of the maps, and there's one that's sitting on average rainfall for the next 3 months, there's 3 on average drier and 8 that's sitting on drier. So that's a fairly strong signal. In our experience, when more than half of the models are sort of skewed either on the drier side or the wetter side, that's tended to increase your confidence in what's the broader direction of things. So that's the overall guide, if that makes sense, Dean. So it's a really good place to start. And there's monthly commentary and little short YouTubes which explain that. And the important bit is no one knows what's going to happen in the next 3 months, but the modelling is just trying to pick up where's their warmest sea surface temperatures, where's all the cloud heading to, and some years it might only be every second or third year when there's a clear signal like that. So certainly with the current outlook for the vibe for the summer is drier. That doesn't mean we can't pick up a thunderstorm or something, because that's part of the, while it might be dry, we still know if you pick up a thunderstorm you're in the right spot. How you respond to that's pretty important. So I'll compare that in a minute, Dean, with the 3 different forecasts. I guess what I've sort of talked about here has been all about the climate variability. And a lot of the discussion is, well, what's the difference from good old-fashioned climate variability to climate change? And you can see here, if we talk about temperatures, the dark blue here is, this is from 2010, coolest year on record in these parts, but hottest on record over here. So I'm going to show you the last sort of 100 years of temperatures across Australia in this next slide. So you can have a look to see if you can notice any trends there. So it starts in 1910, maximum temperature deciles. So you can see each sort of decade playing out there as it'll scroll through.
The trends.
That's getting pretty obvious.
That's a bit scary.
So there's always a lot of discussion about what's variability in climate change, and we've always had variability. So there's certainly plenty of variability in the rainfall, but you can sort of see there a lot of the climate change stories largely around this temperature change. And and it's interesting because as a kid I remember hot days, but it's just the difference between how often and the string of them that's sort of creeping up behind us.
That's very
there's the temperature trends for Southeast Australia. And I guess the Bureau sort of explained this. This is just put in seasons for summer, autumn, winter and spring, but we're squeezing in an extra month of summer. And one of the warmest seasons, fastest falling seasons is spring at the minute. In the last 10 years, we've only had two that have sort of been a bit below average, and quite a few have been between 2 and almost 3 degrees warmer. So that's pretty much getting October temperatures in September, November temperatures in October, and it's so while we've got rainfall variability, we're squeezing an extra month of summer from a temperature point of view. So that's part of why our summer season's getting bigger, and why there's a bit of pressure on our autumns and springs, and how we adjust to that sort of change. And there's a bit more of that coming, I guess. There's just been recently climate change projections for Victoria that have been updated, which is really looking at the sort of weather models and climate models and saying, well, here's the trends and we know what's happening with certain parts of the climate and how might that go in future. And basically all of the models are very confident about how that warming trend continues. So the big question mark is, what do humans do in the coming decades about the amount of greenhouse gases in the atmosphere? Because the greenhouse gases were discovered I think back when Castlemaine was in the middle of the gold rush, there was John Tyndall was doing work and had teased out which gases in the atmosphere actually trapped heat. And so it's very solid science, and the broader story is just the more heat-trapping gases you put up there, the more we trap heat in their inner atmosphere, and the outer atmosphere is actually cooling. So we know it's not solar cycles and things, it's just we're trapping more heat. So the big question is, over that next century, do we warm up by 1.5 or 2 degrees if the world basically heads on a low emissions path, or business as usual with high emissions, it's 4 or 5 degrees, and it keeps going after that too. So pretty important decade or two ahead of us, because we've got all the solutions in front of us to do something, or we could stuff this up. So it's certainly a time to be active, and it's good that you've got programs like what you've got up there about what we can all do locally.
So, Graeme, just got a question here, if we may.
Yep.
Yeah, Graeme, I just want to ask a question about, do you have models or any kind of quantification of effective rainfall in a place like Castlemaine? Because obviously the rainfall's up and down, and sort of overall the rainfall hasn't probably changed that much, but the big difference is temperature increases, which is the number of the increase in average temperature, the number of hot days, evaporation, and the intensity of rainfall. So that's had a big impact, I think, on the effective rainfall, soil moisture. Is there any models on that for this area?
Yeah, well, all of that stuff does get modelled, and you're quite right. Like there's a lot of different things in the mix here that are changing, because the pattern of rainfall, in terms of if you warm up the atmosphere, you actually increase rainfall intensity. So it can become more patchier rather than general rains, and you might get less rain on average, but you might get shorter, sharper events, and that's what a lot of farmers have been noticing. And that's back to what can you do on farm to try and slow down that movement of water and get it to soak into nice spongy soil, so it's there for plants later. So, and evaporation's a key one. We know certainly wind's a really key one, and I just look at this new modelling for Victoria, which I've just taken one image out of it, but it's just a bit of an example of if we don't get our act together on reducing emissions. So it's basically a weather scenario, maximum temperatures for an extreme heat day under a high emission scenario. So that's if we keep median high. And this is for the 2050s, where Melbourne reaches 50 degrees and even high temps inland. So there's a warm bias down here in Gippsland, but it's basically saying it's not the hottest day in simulations, but it's indicative of a very hot day in 30 years' time, if across the planet we keep putting record amounts of emissions in the atmosphere. So you can imagine that sort of thing about how that really changes the dynamics of what moisture we have in on our farms and the amount of evaporation and demand on plants and animals. So I guess there's certainly there's some big risks with all of that, but it's also what gives me hope is we've got plenty we can do about it. And when I look at, we do sort of climate analogues, if you see here on this sort of map, those ISO heights are 1 degree ISO heights, so on average for the whole of the year. And so if you go towards the north, there's someone already farming in a warmer and drier climate. Now, there's very different systems to how they're making that work. So the agriculture, like right globally, there's amazing things that are happening, and people growing food and fibre in all sorts of climate zones. So the climate zone doesn't decide. But the big challenge for us is as we change from one sort of climate pattern to the next, that is a real challenge. And one thing that has been observed too is just in the past 20 years that our rainfall seasonality, is pretty much the winter dominant zones are shifting south, and so every now and then we're picking up a bit more summer rainfall, but it's not reliable rainfall, it's more opportunistic. So that's a real challenge for farming, for how you set your farm up to make the most of it when you're in the right spot and you are getting good rains, and also if a portion of that's coming in bigger dumps or typically out of season, how you manage that. So the weather forecast stuff, I guess, and I'll send some links to Dean, which has got some of my favourite links for weather forecasts, but I just want to explain the difference between weather forecasts and seasonal forecasts and the climate change projections. And weather forecasts, say for the next week, they're the highest confidence, and they give you a forecast for the same. We know that, on day 3, it's going to be this many degrees and here's expected rain. Day 1's more accurate than day 8. But it can vary between models and individual model runs, so no one really exactly knows what's going to happen in 6 days' time. So sometimes the models all agree, and sometimes for extreme events they can vary a bit. And the big curveball for weather forecasts is around thunderstorms and extreme events. So while they might be able to predict that there might be thunderstorms in 3 days' time, they don't know until the thunderstorm where it actually starts. So you might only have an hour's notice about where they actually happen. So and those events you can pick up 50 or 100 mil, and so I know a lot of people grizzle about the forecasters getting it wrong, but saying, well, you can't, you can forecast thunderstorming conditions, but really where that thunderstorm's going to form, no one's quite sure until it actually happens. So that's the weather forecasts. Seasonal forecasts are a bit different. They don't really know what's going to happen in sort of 6 weeks' time, but they're not flying blind either, so they keep running the weather models, and they give you probabilistic forecasts. So they don't say that, in the second week of January it's going to be, you're going to get 50 mil. What they do is they look at those sea surface temperature patterns I was talking about, where all the cloud is, and they run the weather models, and the weather model might run 100 times, and 65 of the model runs might say Castlemaine's drier, but then 35 of the model runs might say Castlemaine gets average or wetter. So that's important difference in the probabilistic forecast. They're sort of hedging their bets there because they just run the models and then give you that probabilistic one. But anything can happen. And with the climate change projections, there's really high confidence in some elements, such as that increased trapping of heat, things warming up, and the poleward shift in all of our weather patterns. So things get hotter at the equator, the tropics expand, and everything gets nudged towards the poles. So that's really quite confident. We're probably more confident about that than we are about, the 3-month outlook. And it's measured physics in the atmosphere. The predictions can change between different models, and there's a lot of sort of potential curveballs in the system depending on how, like 90% of the extra heat at the moment is going into the ocean. So there's big questions asked about, well, how might that influence the El Nino Southern Oscillation or Indian Ocean Dipole? We know the Southern Tropical Ridge, which is where the high pressure patterns sit, are getting stronger. The Tasman Sea is one of the fastest warming areas you see on the planet, and So if you repeat the last 100 years of weather patterns, you don't get the same result if you've suddenly got an area of sea locally that's a lot warmer. So plenty of curveballs in there, which can be a bit frustrating for farmers because you're saying, well, you're not really guaranteeing anything. It's more taking away some of that certainty we had of good old-fashioned variability and adding a bunch of new curveballs. So I guess I'm working towards Dean.
Yeah. Question. I mean, this is all fantastic stuff. Just wondering whether the models actually are getting much better over time with machine learning and AI and that sort of thing, or whether they're pretty much stabilised and you can only do what you can do with them.
They're getting better mainly because it's all calculations of measurements, and there's satellite feeds, and there's a lot more data to feed in, and the models are getting better. I guess one of the challenges is just where you have confidence in models. So what I've given there is a little gold star to where the models are most confident, and I think there's probably a lot more surprises in store because while the climate change models are pretty good at picking up those increased temperature, there's some really big questions about, well, how will the Pacific Ocean, where is all of that heat that it's absorbing going to end up? If it starts ending and sitting in one spot more than another, then that has real potential to change the nature of the El Nino relationship. And same with the Indian Ocean dipole. The last 20 years we've had a lot more dry phases of the Indian Ocean dipole than wetter phases, and there's an open question there about what's happening with extra heat that's sitting in the central western part of the Indian Ocean. So those sort of things have potential to be pretty important, but they're probably not well captured. And my advice to farmers is that by the time the scientific community's understood changes in one of these big global drivers, we'll probably have had to have gone through 30 years of something actually happening before the science is fully captured why. And in the meantime, farmers have had to just deal with it because we're out there growing food and fibre and getting on with doing it with whatever the weather spits out. So the big challenge is how do you set up your farm to deal with coping with historical variability and a bit extra that might be thrown at you. So I guess that's, when we talk about the broader challenge of, my next slide's on the sort of climate adaptation bit. This is just from the carbon and emission story. We know there's lots of solutions in front of us, and there's a big transition of energy and from fossil fuel energies to clean energy, and that's going to be a really important part of the future, and I guess part of agriculture is working out, well, how can we participate in that? And
Graeme, we've got a question for you, if it's okay just to interrupt you from time to time.
Yeah, go for it.
Graeme, can I just ask, with seasonal forecasts in autumn, how reliable are they compared to other seasons, and what sort of models do they use for that?
Yeah, as a general rule, we're more confident in looking at seasonal forecasts, and we trust them a bit better from winter through to spring. There seems to be a bit more correlation, and we certainly trust them a bit more, especially when you can see it's a year where there's a climate driver that's actually an active climate phase. So say for this year, in sort of May, June, a lot of the models were thinking the Indian Ocean dipole was going to head into its dry phase, and as more and more models were expecting that, and then they're starting to predict drier. As you go from month to month, and then you start to see the clouds start to disappear up there off Sumatra and all head out into the Western Indian Ocean, they're things which give you a lot more confidence in a forecast to say that, well, if you run a lot of weather events, based on this situation, that where there's just a bit less moisture likely to be feeding into our weather patterns. Now, when it comes to autumn, and when it come out of summer and into autumn's sometimes really event-driven. So you can snag a rainfall from any direction. So the seasonal forecasts aren't completely useless, but we just think they're less reliable as an indicator of what's going on in autumn, because you can snag a big March thunderstorm and then something else in April, and your season sort of kicked off where in our sort of higher rainfall times of the year of winter going into spring. If there's a climate driver playing up, that's when it's more going to show. So that's sort of our reading of it. And we use the analogy, it's a bit like your confidence in your footy team, that in February, March, everyone's footy team's going to be the premier. and you're all up and about and everyone's attending training, but your confidence in your footy team's form and where you're going to end up at the end of the year, you've got a better guide in July because you can actually see how good your footy team's playing. And it's the same for the Oceans. In autumn, the Oceans, and it's not always clear what they're up to, but if they're going to head into a strong phase, normally by June, July, we're starting to get a good heads up. And so that's, I hope that helps.
Thank you. Graham, question on what you got up on the screen there now. There's two questions. A, the context of the nitrogen fertiliser and also the livestock. Now the inference there is that your livestock, the ruminants, are putting out lots of methane. Have you aware of the term photooxidation?
I'll just run through the context of what I've got up here, because I guess a part of growing food and fibre for the coming decades, there's a strong man, I've got to grow what the world wants, but I'm just sort of looking across the emissions. These are the action areas in terms of lots of activity that's around renewable energy, vegetation on farms, livestock productivity, soil management is such a critical one, and the fertility side of things, I guess. So what these are is just saying these are all action areas on farms of how we improve that and dealing with both climate but also understanding the emissions and carbon side of things with each of them. So and each of them have a fantastic array of sort of solutions and stuff in there. So it's just they're talks in themselves, just getting into each one of those topics. So I just was flagging this as it's little gateways into all of the good stuff that's happening, which I know you're going to be talking about this on your thing. The bit I wanted to, I've shown you some scary slides here on the temperature stuff, if we don't get our act together, but here's an example, say California since 2000, they've been growing their economy and they've been doing lots of different things to reduce their greenhouse gas emissions, and there's about 20 other, I think they're in the top 6 size economy, so there's about 20 other countries that are doing that as well. So it's just proof there to show that we can, improve our economy, improve our lifestyles, and reduce greenhouse gas emissions. It's not an impossible task. It is just let's get on with all the different ways we can do it. And I'm just finishing off here, and we can go into questions or what have you. But these are the things that we see right across agriculture that people are really applying on their properties and in their districts to try and get better set up for managing, what's good old-fashioned variability plus plenty of surprises in store. So new technologies, innovations on farm and regional infrastructure, especially around water security and how we manage fodder. But we've got lots of great extra things in communications that help us. Our farmer showed the other day how good it is just on an iPhone. You could just look up the latest sea surface temperature map and he carries around, and that all helps him. You couldn't have done that 15 years ago. Importance with our links with global markets and biosecurity, that's really important. I know in the 82 drought, I remember there was a lot of sheep that were put down on farms because there was no sort of market. Since then we've got a stronger domestic and export market, and so even when we've had dry seasons, that we've had outlets for them, so they're really important. We see a lot, Dean, the challenge of managing businesses between the volatility of droughts and good years, and that probably there's this, in a good year you can potentially make more money than ever in farming and everything goes right and the season's right and the products you're growing are good prices, but within 18 months you could be at the bottom of the cycle. So managing that business variability is becoming more and more important. And I guess what you talk about today is all around the farm plans and really healthy soils and the importance of that, natural resource base, which is absolutely critical to deal with, bigger fluctuations in weather. This is the stuff that, farmers and what you in the room have got control of, which is much more fun because you're actually more empowered in doing things about that. You've got control over that and learning off your neighbours and getting together with good knowledge networks and all of that stuff is, that's as good as we've got. So I hope that's of use. I'm going to finish up there and appreciate we could probably repeat and had about 4 different topics we could get stuck into just on that topic. So I hope that's okay, Dean.
Yeah, no, that's terrific, Graeme. Thank you. I'll just give a round of applause. And you want to tell us just quickly, since you've put this little promo on the last screen here, the dot break, that's Dale Gray's link, is it? Is that right? The podcast?
Yep, that's
sorry.
right.
What is it again?
Yeah, if you drop an email there, Dale can subscribe you to the list, or that website, agriculturevic.gov.au/climate risk, you can just subscribe there on the website, and it's got access to it. It's got a few other things there, but you can just subscribe, get that monthly update on the forecast of the break, and a little YouTube comes with it. And it's interesting because there's a lot of people saying this is complicated stuff to make sense of. So often, like most of us, you just learn one season at a time. When a season's changed and they've talked about some part of the Indian Ocean dipole, and as you watch it, then month to month see the cloud disappear from where it should be, it just starts to help you understand that, I can see how these things start to influence our part of the world. But certainly there's no perfect forecast. These longer term forecasts just give you a bit of an idea. In some years, like I was saying, might be only once every 2 or 3 years is a strong outlook for drier or wetter. And this particular spring we certainly had a stronger, the majority of the models are thinking drier, and that seems to still be the outlook at the current time.
Okay, terrific. And these slides, will they be available to share with people, and particularly those who are not here today?
Yep, definitely. I'll email them through. I'll email you too just some links of different weather forecasts that people can have a play around with, which are useful. So there's weather forecasts, there's one sort of thing, then there's the season forecast, and then some of the other climate projections. So they're actually a bit quite different, and there's not many places we can go to get them all explained together. But I'll send you through that link as well, Dean.
Yeah. Okay.
Can I ask a question?
Ask him, and then we'll take him off the board too. Yeah.
Graeme, I think Dale's YouTubes are fantastic. Just to really have a lightness about learning how to use those climate tools that he talks about. So I think keep encouraging him to do that with his footies and his fry pans and things. One of the things I'm interested in is how do we draw rain to us? Like, is there some way? Is there some way that we can have an effect on climate where we, plantings that we do, or how do we get the thunderstorm to come our way? Is there anything that we can do
At that micro
as human
level.
beings?
Yeah.
No, I'm serious. I'm being serious here.
Absolutely.
To really encourage that weather our ways. If we did a mass planting in central Victoria, would it affect the rainfall in that area? Or?
I think there's a bit of stuff with microclimate and things that we can certainly, adjust climate at a local level by, just by the things of having a sheltered farm versus a farm that's exposed to hot northerly winds and all of that. So there's certainly things we can do at that microclimate level. But when it comes to the atmosphere and, the troposphere and thunderstorms and rain events, that's all to do with what's happening in the 13 kilometres above our head.
Yeah.
And so I hear a bit about people sort of seeing straight lines where there's vegetation and what have you, but that might help with a bit of cloud, or it might change a bit of albedo for temperature, but it sort of doesn't take a really dry pattern and suddenly make it start raining, because you're talking about the physics that are happening in the 13 kilometres up. So that's so I think what's under our control is really trying to set up those farms that have that microclimate, and one of the biggest drying effects is actually wind. So keeping wind off your farm and places that are well set up with shelter belts and stuff is one really good example, because evaporation really goes off the scale when it comes to wind. And the other bit is just the condition of soil and the good ground cover for soil, the things that the health and quality of the soil, which I know this is what a real focus of what you're talking about with your program up there, which is just how do you try and help in a say 550 mil rainfall zone, each square metre of your paddock will get 550 litres of water fall on it for the year. Now, if you stacked up 550 litres beside each metre, you'd think you've got ample rain there to grow whatever you want. So part of the challenge is, well, what condition is that soil in for whenever you get that rain to soak into a profile and then have it there so that the plants can extract that out, when they need it. So I think soils is pretty exciting because it's under our control and that certainly helps at that microclimate if you can start to store a bit more water in your landscape. But it doesn't bring thunderstorms necessarily, or there's no product we've got yet that you can get your mouse and double click on it and drag the rain over to your part of the farm. Imagine the arguments if you could.
Yeah, I have a question just on the wind aspect. If you can reduce the average wind velocity across your farm on a per day basis by half, do you have any feel for the desiccating benefit that would result in?
It's really a good question because there's been quite a lot of science done on shelter belts over the years, and it really, my observation of it all is that it all shows some benefit. There's obviously against the trees there's a bit of lost production because of brood competition, but then further up the paddock you get these beneficial bits. But it really varies depending on the particular crop, the season, and if you got say 4 days of strong northerlies at a time when that crop was really sensitive, and even things like cold events. We've still got the biggest block of ice on the planet to our south, so when we get strong southerly weather events, we can still get major cold events, and certainly at lambing times and off-shear times and stuff, we've seen people with good shelter belts and woodlots on their farms where it saved them $50,000 in one event just by having somewhere safe to put offshore sheep out of harm's way. So it's interesting, the broader value of having good vegetation and protection on your farm. Sometimes it's there in sort of some 5 and 10% production benefits for a crop, but other times it can be the difference between a few hundred dead ewes versus everything is avoided a big climate event. So there's no simple answer there, I guess.
Sure. Question,
right? Prediction from the sun activity, is that taken into account with the modelling and everything? Like this particular dry event, I understand has got a lot to do with the sunspots and everything happening at the moment. So is that taken into account with predictions and everything, please?
Yeah, there's a fair bit goes on about looking at the sunspot activity, and there's also a lot of stuff there's pretty popular websites, but it's not. Doesn't appear in the peer review research because sometimes with all of these weather things, and there's some talk about moon correlations and all sorts of stuff. Is that there's one thing to have a correlation, but peer review science is where you're showing that there's show us the physics of the causal link between how one thing affects another, there's certainly the sunspot stuff doesn't come through in the peer review papers that I read. And it's interesting, they know a lot about the solar cycles and there is different phases there, and even with the climate change stuff, it's in there that the difference between the sort of 11-year solar cycle is just a really small component of the amount of temperature changes that are happening at the minute. So I guess I'm a bit sceptical there of some of the sunspot stuff, and happy to see it when it comes through the peer review papers. Yeah, and it's a challenge for all of us really, because at the moment we can all get any website material that we like to listen to, and there's some pretty good storytellers out there as well. And like I said, you could someone could explain the other day saying you could explain that there's a lot more rainfall in the months when we're playing Aussie rules football, and it's a lot drier when we're playing cricket. And so as a correlation, you could just graph that and show that, and and say that it's cricket that's causing lower rainfall. So if we played footy throughout the whole year, we'd improve our rainfall. Now that's a good correlation story, but the job of scientists is to work out, well, show us the physics of how that actually happens. And of course, none of that would make it through the peer review process. It's a pretty brutal process. So I hope that helps. Most of the current dry has been put to the big, there's a really strong Indian Ocean dipole event at the minute in the dry phase. And added to that, the subtropical ridge, which is sort of where all of the high pressure patterns sit along southern Australia. In all of the climate change models and what they've measured since in the last 30 years is that pressure pattern is getting stronger. So we've got a bit of a double combo that's happening at the minute.
Thank you.
Okay, thanks, Graham. We just a couple of points that we captured at the beginning. One was generally around bushfire management. So, did you ask that? Yeah. So, what was the nature of your question specifically?
It was one of the things I'm concerned about with the changing climate. Being in central Victoria, looking after remnant bushland and farming, creating those areas for habitat and to break the wind down, protect the soil, allow the birds to move in and out of farming land into that regenerated area, and then also managing bushfire with all of that.
Yeah, no, that's a good question. And I guess those 4-page Bureau of Meteorology brochures, they're really good to have a look at it because they talk about the sort of changing temperatures. There's new climate change projections for Victoria. They've also got regional fact sheets on the summaries of that, and it talks a lot about projected changes in fire danger. So we've always had fires, but it's just that window of opportunities a bit longer. As we squeeze in a bigger summer, it just means they can occasionally start a bit earlier, and we're in some of that risk zone a bit longer. So when it comes back to the farm level, most of these things, and whether it's about running out of water in a drought or having soil blow away because it's been overgrazed or being protected against fire, they're all risks that have been there for the last century of farming, but some of them are just heightened in terms of, well, we've really got to be on our A game for how we're set up to deal with that. And some of these risks are just getting a bit bigger. And what do you do differently to cope with it? And I guess that's the challenge because, and a lot to learn from when you look at people that are farming, 100 k's to your north or what have you, about how are they making it work? What's different? What can we borrow off them for what's working to deal with what's sort of essentially a bit of a warmer landscape? And then, so that just makes those things more important, I guess. There was an early question too around the insects, and I guess the broader story is that there's a heck of a lot going on in the insect world, especially in agro systems, and part of it is creating the ecology on a farm, agro-ecological systems that, what are the nectar sources and habitat sources and feed sources that you're creating on your farm to have sort of buffers for a broader range of insects and birds and biodiversity, it's really important. Broadly, as climate zones shift south, where that brings all sorts of new things with them. I guess that's part of the challenge, and that's obviously with fruit fly and things like that. But Victoria was once too cold for fruit fly to hold over here, but that general getting milder has allowed them to be a lot more comfortable in parts of Vic.
Okay.
So I better finish there, Dean, because you've got some other great speakers there.
Yeah, no, I think I think we've covered up all the other points actually, Graham. I'm just checking my list here. So thanks very much for your fascinating talk, and I'm sure we've all taken 1 or 2 points at least away that we can put into use or affect our decisions. So thanks again.